In the previous video, we saw how to fix bugs in servlets and ensure that they're working properly. But sometimes just working isn't enough. If a particular servlet is going to be accessed millions of times by thousands of different computers, then it's also very important to make sure it runs as quickly as possible. Even small gains in performance will add up over time. There are essentially two components to performance improvements, and we'll see how each of them relates to common performance metrics. The standard method of measuring theoretical performance of algorithms is called Big O notation. In this system, the speed of an algorithm is defined as the relationship between the number of operations required by the algorithm and the size of its input. For instance, a program that takes in an input and simply writes it to a file runs in O of n time. This means that for an input of size n, the program must complete something on the order of n operations. In this case, it would complete one operation per piece of data in order to write that data to the file. A good sorting algorithm, on the other hand, takes about O of n log n time. Whereas the writing program will take twice as long to process twice as much input, if you double the size of the input for a sorting algorithm, it will take O of 2n times log of 2n, which is approximately equal to 2 times 1 plus log 2 over log n times longer. This scales up a little bit more quickly than with the writing program. Other algorithms scale up even more quickly, taking O of n squared, O of n cubed, or even O of 2 to the n time as the input grows. Obviously, the goal is to get the smallest big O running time as possible. That way, you can deal with larger amounts of input without worrying too much about the number of operations growing rapidly. The beauty of Big O notation is its simplicity. You only need to consider the relative relationship between input and time, and you can freely ignore any constants, any smaller terms, or any extra fixed costs. This method is called asymptotic analysis because it is meant to apply to inputs as they grow extremely large. Generally, we assume that if the input is going to be small, then the program can run pretty quickly anyway, so it's not that important to optimize it. What we're trying to optimize for is very large inputs that might take minutes or even hours to run. Based on this, there's a very natural division in optimization into two parts. First, there are the incremental improvements that reduce fixed costs or save proportional amounts of time. And second, there are algorithmic improvements that reduce the big O of the entire program. Improving algorithmic complexity is obviously a very complex topic, and there is often no easy answer or one-size-fits-all solution. The best way to improve asymptotic complexity is to research the algorithms you use and ensure that they are the most efficient for your situation. There's been a lot of research done on many common algorithmic tasks, so you can often find much faster algorithms than what you would normally consider. As you consider the incremental cost of your algorithm, there are a few general tips to keep in mind. First, avoid repeating work. If you calculate a value in one part of the program that will be used in a different part, then it's usually better to save and load that value rather than calculating it twice. As a general rule, data storage is cheaper than processing power, so it's better to store more data than you need and be able to access it than it is to overwrite data immediately and then maybe have to recalculate it later. Second, use built-in Java functions whenever possible for simple tasks like sorting, multiplication, or matrix operations. The Java library is designed to use the most efficient algorithms possible, including some very complicated functions that you probably wouldn't want to replicate on your own. For instance, concatenation is much faster using the string buffer than using the plus operator. So if you have large strings of text that you need to concatenate, you would definitely want to use the string buffer. Similarly, the servlet output stream is more efficient than the print writer for transmitting binary data. Third, recognize that the processing doesn't just occur on your end. Because we're dealing with servlets here, the client must also receive the data and then render the page. Therefore, you should flush the data you have as soon as possible so that clients can start to load the first part of your page without waiting for the entire page to render. For instance, you might first flush the header, then the navigation bar, then each piece of the body content. Finally, use local variables whenever possible. Accessing a computer's main memory takes literally thousands of times longer than accessing the current cache, and accessing data over the internet takes longer still. For servlets in particular, This means that you should cache the data that you will use more than once. If the data is read-only or will never be changed, then the most efficient cache is the static data cache. If the data will change but only occasionally, then you can use semi-dynamic caching. And if the data is likely to change with every request, then dynamic caching is the most efficient. With these techniques in mind, you should be able to dramatically improve the performance of your servlets and faces.